Welcome to this video. My name is DARSHAN KATGERI and I am working with Jain College of Engineering, Belgaum. In this video, we will be discussing about CAD and computer graphics software with more emphasis on computer graphics software. In the previous video, we have seen in general about the design process. What are the various stages involved in the design process, like recognition of the need and defining the problem and synthesis, analysis, and how these two stages they go hand in hand, wherein there might be a requirement of rethinking, reconsidering, and redesigning something. So these two activities actually go hand in hand, and we have seen about these two activities. Then about evaluation, which is concerned with measuring the design against specifications, and these specifications are laid down during this problem definition phase or stage of the design process. And then finally about presentation, which is more concerned with documentation and various kinds of drawings of different components of the product and so on. So we now have a general idea about this design process, and we also discussed a little bit about this CAD, right, and how this CAD can be used to increase the productivity and how it can be applied to this design process. In this video, we will be discussing more on these particular aspects of CAD, that is geometric modeling and analysis, design review and evaluation, and about automated drafting. So in the slides coming up, we will see more about these things. So we'll move on. In this slide, we will study a little bit about geometric modeling. So the main thing when we are working with a software is that the product has to be visible to us, right? All these softwares, what they are basically doing is they are providing us with an virtual environment wherein we can develop the products, right? So it is very important for us to view the product, to view what is being done, and to view it through various angles. Like for example, I might want to see how it appears in a front view, how it appears in the top view or side view. So one of the main features is that the image has to be visible to us, right? So one of the functions is to display the image on an graphics terminal. The graphics terminal is nothing but a monitor screen. And then how this will be done? So this will be done by storing the images, right, in the memory of the computer. So now we can call this as a mathematical model or a mathematical description, to be more correct. It is a mathematical description, right, which is called as a geometric model, and it will be contained in the computer memory. And by using all the information that is contained in the memory, the image is displayed. Not only this kind of image, but in various angles, in various views of this, in various modes. Like in, for example, we can see that here we have an wireframe model or wireframe mode of this particular model. So like this, there could be a solid mode wherein I can see the surfaces and it gives me a better picture. So all that is important is that the image has to be displayed on the graphics terminal, and this can be done by storing the image in a mathematical description, that is storing the model in the form of mathematical description, and it is called as an geometric model, and it is stored in the computer memory. As you can see here, it is being shown in this particular picture. Then there might be a need to move to reorient the surfaces, to zoom in, zoom out at times. As you can see here that the basic operation of translation, right, or movement from one point to another point is shown here. Like this, we may want to move a complex object, even that is possible in the softwares. We may want to reflect a particular image, like we may have an symmetric image wherein the uh, right half may be similar to the left half. So what can be done is only half of the model can be modeled in the software, and the rest can be reflected on a particular axis. And whenever we talk about reflection, we can reflect it about x-axis, y-axis, or maybe in general any line can be considered as an axis. Sometimes whenever there are small objects, or whenever there is a large assembly, there is a need to zoom in and zoom out. So to emphasize, I have shown this particular image which is zooming onto this India map here. So this is just to show the zooming effect. So like this, there might be a need of various things which may be provided by the graphics software, and which will help us to put our idea in a much better way. Then to speak more about models, we have 2D models and 3D models. What this means is when we are talking basically about 2D, we are talking about drawings like this, right? And when we talk about the 3D models, we are talking about views like this, especially in isometric view, that is as it is visible in this. So you can see that this 3D models or this isometric views, they give us a better picture of how the model is and how it is going to look. And these 2D models or 2D drawings, they can be useful more for production purposes, for manufacturing activities. Production drawings can be prepared on drafting environments, which is provided by many of the graphics packages. So here you can see that we have a lot of GD&T going on here, that is geometric dimensioning and tolerancing, and important or salient dimensions being given, and what is the datum, and all those things is given in detail in this 2D drawing. This 2D drawing may be obtained from the 3D models, right? Most of the software packages these days have this convenience feature wherein you can convert this particular drawing, that is this 3D model, into 2D models, and you can generate 2D drawings like this. So there is no need of developing these drawings separately. Once we prepare the model, this can be easily got from the 3D model that is being prepared. So these are very important facilities that are available in the softwares, and these are in fact the two types of models, that is 2D models and 3D models. Next we have wireframe models and solid models. As in the previous slide we have seen the image of an aeroplane. It was basically a wireframe image. What wireframe basically means is that the surfaces or the solid body is not shown, and the model in the form of a mesh like this, it looks like a wire is being wound around, right? In this form it is being displayed. So this is called as the wireframe model, and then we have another type, that is solid model. We see that this is a picture of a torus, right? So wherein we have one circle, and this circle is rotated about an axis. So the axis is here at the center, and then you can have one circle, and then you can rotate the circle about the axis, and you will generate this particular torus. So this is the solid model. So many a times solid model gives us a complete understanding about the appearance of a particular object, and it is in this mode wherein we can see after application of a texture or a particular color how a particular model is going to look or appear. So, but this is computationally very challenging, especially when there is a big assembly or a complex model. Sometimes the system may respond very slowly if we are working in this solid mode. So at that time, what we can do is we can just move on to this wireframe mode and continue with the modeling, right? But this gives us a clear picture. But as we have seen that this is more computationally challenging, sometimes it becomes necessary to work in this wireframe mode. So they are of practical significance to the designer, and they have to be used very wisely. Then next is that by using these softwares, we can calculate many things. Once the model is ready, we can do a lot of things, like for example calculating the mass properties, like for example what is the volume, and then what is the area, then moment of inertia, and other things can easily be calculated by the software once the 3D model is ready. And then this can be used in assembly to perform inference checking. Inference checking is important. Sometimes there might be a need to check if there is any collision in or happening which may be dangerous. So such things can be checked in the softwares. Also softwares like CATIA, they provide something called as DMU, that is digital mockup, right? Wherein you can sort of animate the things and further visualize what are the various motions going around, and what are the distances and displacements. All those things can be known by using the softwares. So by using these features, a lot of things may be efficiently managed, which otherwise would be very difficult. So these are the features of the softwares that help us. And the last thing is we can see the product in different colors, and also we can animate a particular product, like you can give a 360 degree view to a particular product, and check how it appears in various angles, in various colors, in various lighting effects. So all of this is very important as far as the software package is concerned. It should have all of these features which will facilitate the process. So yes, in this particular slide we are basically going to talk about the analysis part, right? So as we know that there are many analysis softwares, ANSYS being the most widely used software. And these softwares, they can do many things again, like for example the stress and strain calculations, and they can generate graphs like this without doing much of calculations or manual calculations not needed. But these softwares have ability to generate such images and such informative graphs which may be used. So a lot of time which would otherwise be spent in doing such activities like developing graphs and calculations, are now not necessary because the computer will do all the calculations and graph the plots for us. So these can be used to analyze the particular behavior of a product. And we also know that we can easily change the materials, various boundary conditions, temperature. So these can be easily managed in a software. Also in this you can see the heat transfer analysis, which is shown in different colors. So the persons with the heat thermal engineering as a background can easily understand and analyze these problems. These baffle plates and the flow and the heat transfer may thus be analyzed by using these softwares. Then you can see in this particular animation that we have a car, and in this we have certain structure which is falling down. So these can also be analyzed by using the analysis software. But for this we have to do, especially for this car, we have to first generate or prepare a model in one of the modeling softwares, and then this has to be meshed, right? So there are many meshing softwares also there that are available in the market. The most widely used is hypermesh software. So all of this will be meshed, and while meshing we have to be very careful, especially at the interfaces like these, right? Wherein there is a transition and a lot of continuity also has to be given to the mesh. And then when finally application of the load is done, then the software will analyze. It will take a lot of time to analyze. Sometimes it will take even days. If the project is a very big project, then the time could be in terms of days to analyze all of this and then finally give you a result like this. And various kinds of analysis, that is computer aided engineering, we call all of this as computer aided engineering. So a lot of analysis, various kinds of analysis are easily possible, and they can be easily done in the softwares. And especially with the newer softwares, they are becoming seemingly easy to use software. So all that we have to know is which module to use and where to click, and the software takes care of the rest of the things. So they are very powerful softwares and graphic packages these days, which will help us, or which are helping us to improve the productivity and spend a lot of time in understanding the things. So in the next slide, yeah, this is about computer aided engineering. This slide was also about the same thing, wherein we can do a lot of stress analysis, heat transfer analysis, dynamic simulation. Here also as computer aided engineering, as we have seen, we can get to know the various mass properties. Like for example, in this particular screenshot, we have mass, we have volume, we have surface area, then center of mass. What is the center of mass? So all of this is readily available. All that we need to do is prepare the model or model a particular product in a 3D environment using one of the softwares. And then rest of these things the software itself will take care of, and all of the calculations thus become unnecessary because we get a lot of information available right away once we prepare the 3D model. Then many a times interference checking is also required, like collision checking. If something is colliding, then it has to be taken care, especially in gear trains and all. This will be used to check the interference. Tolerance analysis and finite element analysis. This is again very important, wherein this particular image you can see that It has been analyzed by using a finite element analysis, and you can apply a lot of forces and then simulate the conditions, and then you will get ready-made results by using the softwares. Then we can have many kinematic and dynamic analysis. So yeah, there are many things which are going to explain all these properties, wherein you can see this particular animation. We can see that the graph is being automatically generated, and then we can take this graph and use it for documentation and understanding purposes, and the very process of doing this manually becomes unnecessary. And then when this is another animation which is showing the movement in the form of animation, and then this is basically about a discrete event simulation. So there are softwares which are available to simulate these particular events. Discrete events basically they mean that events happening at different points in time, right? So, and each of these events after happening, they represent a change in the system. Like for example, arrival of a particular workpiece for various processing or machining operations on a machine center or in a work cell. Yes, that is a discrete event. Or maybe there is a breakdown of a particular machine. Yes, that is also a discrete event. So all of these events they can be modeled and simulated, and what will be the effect of these models, these can also be analyzed by using various softwares. So this particular image represents that, wherein you have a lot of machines, and then you can run this particular simulation and then analyze various results associated with this. So this is important. Also, you can analyze the flow here. You can see flow and other analysis like electrical analysis and other kinds like wind flow, magnetic field. All of these can be studied thoroughly by using these softwares or graphics packages. So the practicality of these softwares is very, very important. Next, we have design evaluation. Now, evaluation and review, and these are the things which are involved in this. What are the various things we will just see? The first thing is automatic dimensioning. Automatic dimensioning, it ultimately means that whenever we have modeled something in a particular software, and when we go into 2D, then we don't have to do the dimensioning, redo the dimensioning by using the commands. Most of the dimensions, they can be retrieved. So there will be a command called as retrieve dimensions, and if we utilize this command, most of the commands they can be automatically obtained. So we can use this particular facility in dimensioning, that is nothing but automatic dimensioning. And also it can be used for error checking. If there is any error, then these can be used, the softwares can be used for the error checking and animation of discrete event simulation. So here you can see that this is already explained in the previous slide. Here I have put up two more slides which ultimately are showing you about this discrete event simulations, and there are special softwares for these purposes. And then plant layout, you can see that there is this plant layout. So how is the plant and how is the layout of the plant, it is also important, and all of this can be done by using softwares. Then we have rapid prototyping. This particular GIF or animation shows rapid prototyping. wherein it is a technique wherein the product is done layer by layer, right? So the product is built by a particular machine wherein the head moves like this, and it goes on preparing layers on top of layers, and thus it gives a product finally. And then prototyping. So conventionally, prototyping is basically preparing a small scale model, and a lot of time would be spent on such activities and the testing of these activities. And all of this can now be done in the software, and the whole process suddenly becomes very easy and convenient to be done. So these are all the things that are concerned with evaluation and especially reviewing these things. Then we have automated drafting. You can see this. CAD systems increase productivity in drafting by about 5-fold. So most of the things are automated. So you do it once and then you can reuse the same things. You can retrieve the dimensions. You can create different views. You can create different sections. All of this just by a few clicks. So it increases the productivity, and it is estimated to be around 5-folds over manual drafting. So again, when we are talking about increase in productivity, yes, there is certainly an increase in the productivity, and time is saved. That time can be spent productively somewhere else. And after doing all of this, then there is this presentation and documentation. What you can see here is in this software, this is a post processing. That means documents are being prepared, and softwares are being used to prepare these softwares. Various views are shown, various graphs are shown, and other information which is very vital for manufacturing will also be given in the documentation and presentation. So all of these things are very important, and the use of softwares or graphic packages is justified. And then what are the advantages? We have discussed so much about these softwares or graphic packages, and we have always paid attention to productivity. So yes, there will be an increase in the productivity. There will be a lot of time saved. There will be a lot of effort that will be saved, and all of the process becomes much more efficient and convenient to be done. And the management of these activities like presentations and documentation, they certainly become much more convenient, right? Next, increased available geometric forms in the design, right? So there are various geometric forms in the design, and they can be of great advantage to us. And then we see, after doing all of these, there is certainly an increase in the quality of the design and improved documentation. So it means that there will be some conformance about the activities. Certain things are supposed to be done in a particular way, and they can be done by using these softwares. So, and many things can be efficiently managed. Even an important thing like quality, right? Which most of us speak so highly about, because it is one of the most important things in design. So quality seems to increase by using this CAD, which is a great advantage to us. And the creation of manufacturing database, like what processes are there, the management of documents, drawings, processes, and then manufacturing database like MPS, that is production schedule, and then process planning. So all of these things can be done by using the CAD softwares, which is a great advantage to us. And by using all of this, now we can say that there can be some standardization or design standardization, which is also very important. So all of these are the various advantages of using a CAD system. So we have seen the significance of these graphics softwares, how they are used in the industries, and they seem to increase productivity, seem to improve the quality, and yes, it becomes very important for us to know about these computer graphic packages and their role in engineering. So we have studied a great deal about these CAD packages and their importance. Thank you.